Hello, thanks for joining into the webinar. We're going to talk today about options that we've built into Petrosys for doing conversion of raster images into data. The format of this presentation is we're going to start off just showing you where to find the option, give you a quick overview of what it does, and then Eric Wright, our support guy in Houston here, is going to run through a demonstration of the raster grid operation to show you how you can convert raster images into gridded data. We'll have quite a few examples that we can actually show you, and then we're going to segue into the more complex task of raster to vector conversion, ending up with a demonstration of some new functionality we have for converting contour images to contour maps back from images into actual vector data. Some of the examples we're going to be working through, wide variety of different types of grids, South African solar potential, the thickness of some sands in the Middle East, some depth maps from the North Sea, various bathymetry examples, and then later on we'll actually show you some of the things that don't work quite as well with these algorithms, because there are limits to what you can do with automation. So to get started, where do you find the option? What's it all about? The raster to grid and raster to vector conversions are part of the standard Petrosys Pro mapping software. So you fire up the mapping canvas and you start off by displaying the image that you want to analyze using the display raster option. The image ideally should be georeferenced, because otherwise you won't know where your grid data sits in the world. You then will apply some clipping to get rid of the title blocks and the other stuff in the image that doesn't really contribute to the data. And then you go into the spatial editor by using the edit option. And the rest of the operations all happen within the spatial editor. Within the spatial editor, there's an option called create grid from raster. And there's also one which is extract vector from raster. You invoke that option, as Eric's going to show you shortly. It brings up another panel in which you can do various operations. For example, you can do further polygon clipping of your image. You can mask the image to remove more extraneous information. You can then do various forms of image processing to enhance the colors that contain your data. And then if you're doing the raster to grid operation, you define a color gradient, which is going to tell the system what values are associated with which colors and how to interpolate them. And then you press the button and you create your magnificent Petrosys grid. So let's kick started. I don't know, Eric, are you all set to give us a quick demo of the solar resource potential of South Africa?
I sure am, Volker. Let me get my screen share going on here. What you're looking at is my Petrosys project. What is being displayed in mapping is a raster image of, as Volker said, South Africa. And the red outline is a clipping shapefile. The image itself is not georeferenced. It's sort of floating in space. When you do this in practice on your own, you will need to georeference it. You can also notice that there's a color bar with this raster image down below. A couple things to note about the color bar is that it's a very stepped color bar, and that, I mean, it's not a lot of interpolation. The values are very discrete, as well as the colors. So that's one of the things that's going to make this particular raster to be easier to take in our raster grid algorithm. So to get started, first thing we want to do when we want to use our raster grid process is we're going to want to display our raster. And to do that, we're going to go to the top here and select Display and Raster Image. And Petrosys accepts a wide variety of image extensions that you can use, so for example, PNG, TIFF images, and so on and so forth. Once you open our display raster image window, the first thing you're going to want to do is select this drop-down box here, and you're going to want to change that to world. Well, the first thing you want to do is load the image, but once the image is loaded, you'll change the drop-down box to world. If you're using a georeferenced image, you will see your georeferencing information on the right-hand side here. I'm not using a georeferenced image, so I'm going to check on the boxes for allow dragging and interactive placement. Going ahead and hit OK. And I'm simply going to left click and hold to drag my image out over where my data set would be. You can see that the image has been kind of placed ambiguously on the map. To make sure it's georeferenced, you'll need to left click once on it, right click, and select georeference image. Since this presentation is not about georeferencing image, I won't go into detail about that, but you can find further help on that on our client portal. Let me turn off this image. The next step you're going to want to do is create a clipping polygon and or shapefile to kind of limit the bounds of your data set. Raster images often come with information such as title blocks, color bars, lat longs that we don't want to be included in our raster grid process. So the clipping polygon is going to help us cut out that extraneous information. To create a clipping polygon, as well as to create a grid from a raster image, we're going to need to open up Spatial Editor. And to do that, the easiest way to do that is to right-click on our image in the display list and select Edit. And you could do this, you could select Edit on any number of files, but this will load up our image into our Spatial Editor module. To create the clipping polygon, we're going to go to File inside of Spatial Editor, and we're going to go to Create. We're going to set the layer type to full definition, and we're going to set this drop-down box to shapefile. While we're using shapefile for this demonstration, please keep in mind we do have other things you can use as clipping polygons or shapefiles. For example, you may have a polygon file from Petrosys that you can use, and so on and so forth. But shapefile is the one we're going to be using for this demo. You're going to go ahead and set the shape type to polygon. Make sure the CRS is appropriate. The attribute definition is not going to be important for this, and you're going to hit OK. Open overwrite. You're going to go down to the pencil icon here in Spatial Editor at the bottom left. Left click once, and then kind of circle your data using the Spatial Editor tools. Once your data is encompassed, and you can see I'm just arbitrarily drawing this polygon here, but you're going to go ahead and save it using the floppy disk icon here. This is the clipping polygon that we'll take into the Create Grid from Raster process. Now that we have our clipping polygon created, we're ready to take this raster into our Create Grid process. The way to do that is to right-click on the image in Spatial Editor and select Create Grid from Raster. I'll go ahead and do that now. May take a little bit to pop up here. Let me try it again. There it goes. Sorry about that. Okay, whoop, got two of them here. Okay, so when you do the Create Grid from Raster, when you start the Create Grid from Raster process, you'll see this window pop up. It defaults to the source window. Your image will automatically be selected for you. The outline polygon section is where we're going to use that clipping polygon that we just created. And again, you can use a wide variety of clipping polygons or shapefiles. It doesn't have to be a shapefile or polygon. We do accept other formats. Once that shapefile is loaded, it'll be taken into account when this gridding algorithms run. Down here in this manual image masking tool is an additional method that we have to eliminate extraneous data from this gridding algorithm. What we're going to do is we're going to select Edit to open up the image mask editor window. Let me go ahead and revert my edits here. When you do that, you'll see your source raster pop up in this window here. And what this image mask editor tool, it's similar to an eraser tool that you may have encountered in, say, Microsoft Paint or so on and so forth. And what it will do, it'll allow you to erase parts of the raster image that you were using and tell it to be discluded or not included from this gridding algorithm. While we do have the clipping polygon available, this is a further tool that you can use. This is great for saying eliminating perhaps annotations like cities. You can see here I have Johannesburg and Pretoria here. I can maybe kind of go over those with this little masking tool. I'm going to go ahead and hit cancel here because I already have a masking image saved. And once you're done with your own masking image, you're going to want to head and save that as well. On the right hand side, you'll see a preview window. It defaults to your source image at first. If we clicked on this masked radio button here, you can see what our image looks like with our masking polygon and clipping polygons applied. The other radio buttons are for extracted values, which will show you the data that's being extracted by this raster grid algorithm, and unmatched values, which are the values that are being left out. Those are the other two important ones. I don't tend to use the preprocess radio button too much so far, but we'll go ahead and flip this back to source image so you can see what it looks like. Up at the top, we'll have an image preprocessing tab we'll now move on to. And this is where we'll do some preprocessing algorithms to further help us take this raster and turn it into a grid. We currently offer 4 selections in version 2020.2. Those are color filter, morphology, blur, and threshold. The color filter acts as a mechanism that you can use to filter out certain shades of pixels or allow them as you so desire. So for example, in this color filter that I'm using, I'm filtering out the shade of black that represents the country outline. I don't necessarily want those to be taken into our gridding algorithm process. I'm also filtering out the black that it's included here in the annotations. It's just one of the ways you can use it. You can also use the color filtering to tell it to only include those pixels, or you can tell it to replace certain pixels of one color with another. It's probably the most useful tool that in this image preprocessing tab. The morphology image preprocessing tool is a thinning and thickening process. It'll thicken or thin the colors on your raster, so to speak, to fill out certain maybe blank areas or so on and so forth. It'll enlarge or decrease the size of the pixels in your raster image. The blur option is, as its name implies, a certain it blurs the pixels in your raster image. It's good to use in very heavily pixelated raster images, and it's similar to a smoothing algorithm. Maybe not the best word for it, but it'll kind of help out maybe areas where, like I said, it's very heavily pixelated. The threshold is a black and white conversion tool. It'll allow you to assign a shade of gray, and everything above this shade of gray will be set to white, and everything below the shade of gray will be set to black. I don't tend to use the threshold image preprocessing much in the raster grid process. For now, we'll just go ahead and leave the color filter on. The value extraction, moving on, is the most important part of this raster grid process. This is where we associate different shades of color with our Z values. And again, this is where that really stepped color bar is going to come in handy. It's a lot easier to work with a stepped color bar than it is to work with a very heavily interpolated color bar. So to begin, what you're going to do is you're going to left click once on this add eyedropper symbol here, and you're going to hold on to it, and you're going to take it down to your color bar, which hopefully your raster image came with a color bar, and you're going to let go of the left click button. You can see here that it's now added a color to my color gradient, and we can use this Z value here to assign a value to it. So what I've just done is I've assigned the integer 9999 to this shade of green that's on my color bar. You're going to want to do the same thing to each other part of your color bar. So for example, you would do it in succession. You would take different parts of your color bar and you would do this until your entire color bar has been filled out. After you're done, you're going to want to save your gradient using the save icon here, and you can recall it later to display your grid or any other grids as you desire. At the bottom here, this color match tolerance gives you a little leeway for when you're working with this tool. It tells you that you don't need to maybe match a pixel of one color exactly. You don't need to get exactly the same shade of orange. You have a little leeway in that the more you adjust this tool. So it'll allow you to give you that tolerance. The downsample rate is similar to a resampling tool. It's good for when you're working with images with large pixel counts. I tend to leave it at none because I think the process so far, in my experience, works pretty well. But you do have the option here to downsample it to smaller and smaller pixel counts if necessary. It will affect the final quality of your grid the more you downsample it. On the right-hand side, while you're assigning this color gradient, I recommend you have it on this Unmatched Values radio button here. And what this Unmatched Values preview window will tell you is the colors and shapes and parts of your raster that you were leaving out. These parts of my raster image are not being included in the subsequent processing. So you can see if I wanted to, for example, pick up maybe some of these oranges, I will need to go on and maybe refine my color gradient a little further based off this unmatched values window. Once you're happy with your gradient, you're going to go here to this output grid tab here. And here are the standard gridding controls that you may have seen in other parts of Petrosys, like the grid create grid process. You have control over things like cell size, extent, interpolation method, and so on and so forth. If I move this window aside, you see this pink little rectangle that's been over my raster image. This is what Petrosys is recognizing as being the extent of my grid. So if you need to modify that as you need, you can use this panel to do so. The generated contours section controls what the contours look like in Spatial Editor. It does not have any functionality outside of the grid when it's not in Spatial Editor. I'm going to leave this as default for right now, and I'm going to go and hit cancel because I don't want to run the create grid process over the webinar because I already have the grid actually made. Let me back out of Spatial Editor real quick so I can show you what the actual final result is. Okay, let me turn off the raster. This is the final gridding result that I got after I did do this a couple tries, but it tends to give me a very nice looking grid. One of the things I was able to do with using Spatial Editor is to take out some of these annotations that may have got left behind in the raster to grid process. You can see here this was formerly a city name. Spatial Editor will allow us to go in and kind of lessen the effects of these kind of artifacts and by interpolating these grid cells from surrounding grid nodes if desired. I think the grid looks pretty well, and generally the functionality works pretty nicely for most rasters I've come across, even ones with very heavily interpolated color gradients. Volker, right now I'll pass it back to you if you have any further comments.
Thanks, Eric. So Eric showed us how you could extract the grid from one particular map, and he's run a couple of different examples. The next one we're showing you here is a thickness map of a sand in the Middle East. And one of the interesting things with a lot of color maps is that the color gradient is not actually continuous, but as Eric was mentioning in the previous talk, it can be quite discrete. So in this map, for example, the colors are constant between the different contour intervals of 20 feet thickness levels. When we convert that to a raster, to a grid, we end up with a pancake type grid. So the grid we end up with is exactly what the contours are telling us. It's a series of flat layers all stacked on top of one another. The next thing you need to do in Petrosys, if you want to turn that into a proper thickness grid, is to use one of our gridding algorithms to switch from that mode to that mode. And the way we do that in the workflow here is actually to compute the contour lines associated with these pancake layers, and then regrid the contours in Petrosys create grid from contours, which is our contour to grid algorithm, and that gives you back a nice smooth surface. So Eric's actually done quite a few different examples here. Here's quite a difficult one. It's a depth map from the North Sea, and one of the complications here is there's lots of annotations and overlaid geological attributes and so on. And we've been able to remove a lot of those by using the color filtering options. So Eric was showing you the color filtering tools, and he used those to remove those annotations and the extra features and end up with quite a good looking grid of the Forties field in the North Sea. Here's another example of some bathymetry maps from the North Sea. This one obviously not such a challenge because it hasn't got a lot of annotation on it. But now we show you one example of something where you potentially can run into problems. A lot of the color fill maps you get, particularly with gravity and magnetics, actually are not just color fill. They actually color fill overlaid on a sunshade or a hillshade. And you can sort of tell that because you can see little shadows around the edges of features there. And that makes it very difficult to do the color matching because the reds on one side of a slope are going to be different to the reds on another side of a slope. And I only had a very rapid try running this particular one, and as you see, it sort of created a lot of meteorite craters around the edge of Australia. So just be aware that your color image needs to be just pure color without the hill shading. Another problem happens if your image is very low resolution and has a lot of aliasing in it. So for example, in this JPEG, we were trying to convert this map from India into a structure that we can use for migration, fill and spill modeling. And when you zoom in, you can sort of see that the colors get quite irregular. So I was finding this one here quite difficult to convert into a structure. And it was about 5 months ago we were doing this. I actually reverted to essentially hand digitizing it in the spatial editor. And I just thought I'd pop this one up because what's interesting with the spatial editor is you can actually run it on a touch screen, which I was doing here with a stylus, which does speed up the operation a little bit, but it's still very subject to your shaky hands. So if you have any feedback on that, please ring our support group and let us know. So I did manage to get a good result of that, but ideally what we want to do is we want to be able to extract the vector data from the raster images without having to be dependent on our sort of shaky hands and manual digitizing. And there's two methods to do that in Petrosys now. One is to use the raster to vector conversion in the spatial editor, and the other one is to use the traditional tracing of contours and faults, but using augmented image recognition, which is what I'm going to show you at the end of this demonstration. So for the raster to vector operations, you start off very much as with the raster to grid. You display the image that you want to extract data from in your mapping window. You georeference it, and you see in the United States we have all these marvelous county boundaries which make georeferencing quite easy. So having georeferenced the information, you then press the edit button and you put it into the spatial editor. And just as with the raster to grid, which Eric was showing, you pick an option, create, in this case, vectors from raster, and it pops up the same image processing tools that Eric showed you. So we have on the left here the tabbed window that Eric was discussing, the image preprocessing. And in the monitoring windows, we have a couple of different options, the source image, the preprocessed, and the threshold. And I'm not going to go through the whole process here, but what we've done with this image is we've applied the pre-processing and we've used the color filter. So you see we have the color filter option there to pick the olive color of those particular lines that we're trying to trace. And then we've selected the option to clear all the non-selected pixels. So in this particular case, the color filter is being used to eliminate everything except for this particular color. And as Eric was talking about, there is a tolerance, so you can let it go a little bit to the reds and the yellows side of the olive green. That's given us a pre-processed image in which everything's been eliminated except for the olive lines. And then the next step is we can use the shape extraction to actually extract the shape. Now the challenge with the raster to vector option is that it tends to like to identify polygons as opposed to polylines. And you see it's gone its own way down here and extracted a lot of little balloon-like polygons. And so the final step in extracting the vectors is really to clean them up and turn them into the actual shapes you want to have. So what I've done here is I've taken the extracted vectors for that shape, and it's left me in the spatial editor. I'm editing the shape that it created, and I can use the tools like the create a polygon from existing shapes to snap a new polygon using the identified vectors from the raster to vector operation. And that's really worth doing if you have high value polygons. So in this particular case, these polygons are quite complex. They have a very difficult boundary for digitizing manually. So it's well worth the effort of running through the raster to vector conversion to do that. In practice, a lot of the stuff we want to do is actually to convert old contour maps to structure maps. And in those cases, we have a large number of relatively predictable lines like contours and the fault outlines that we're trying to turn into vector data. And you can do that in the in Petrosys 20.2. We've added a new function to make that easier to do based on the underlying raster image. What you do is you take your, I'm actually going to switch over to a live demo now, so let me try and bring up my Petrosys map. So in this particular case, we have a map of a structure in the Gulf of Mexico. It's the Grand Isle, which has been operated since the late 1940s. And the first thing you need to do is to georeference that. So I pop the image into my mapping window. And in this case, it was very easy to georeference because we have these GI 39, GI 40 block boundaries we can use against it. So you georeference your image, and then just as with the raster to grid, you go into the spatial editor. So you invoke edit for spatial editing. And in the editor, we're now editing the raster image. So if we wanted to do the raster to vector, we could say operations, extract shapes from raster, and it would go through that process that we looked at with the planning area polygons of the Gulf of Mexico. But in this case, that's not what we're going to do. What we're going to do is we're going to use the underlying image to help us trace the contours. To do that, the next thing you want to do is to create a file to hold the data that you're going to extract. And in this case, we're going to extract contours. So I say extract, create a contour file called dr2.com. And now you're in a mode where you can either be editing the rasters or you can be editing the contour file. And we're going to zoom in a little bit further up here to focus a bit more on it. And if we didn't have the raster image, we could just draw the contours. So we could just go up here and pick a line and draw a contour just as you have in the past. And we pick a level for it and all that. But now with the raster tracking option, we can pick the raster tracking option, which is a new feature, enable that. We can pick the color that we want to track. So just as with the color to polygon option, you could pick the eyedropper, hover over your black. And, I've already done that. You've got a couple of options like smoothing and reducing the noise in the lines that you do. And then because we're digitizing contours, it's giving us the extra feature of just being able to specify a contour increment, a contour level, and a contour stepping thing. And now, when we go to digitize on the map, if we're well away from the image, it'll still be as normal. But if we navigate our mouse close to one of the existing contours, you see it actually picks up, identifies the underlying contour in the raster image, and it turns the cursor into a little hand. And that means it's ready to start tracking. And I can now point at some other point on that line. And you see it'll actually identify that point and it'll track along the line very nicely. So now what you can do, just as though you had an underlying image, vector image already, you can actually use the underlying raster image to identify line segments that you want to include in your line. Now you're going to ask me, well, what happens when you use the annotation? Because it's going to try to wrap itself all around the annotation in a weird way. So we've allowed for that. You press the space bar and it temporarily disables the tracking. Go to the other side, you've captured the point to the other side of the annotation, and then you press the space bar and it reverts back into picking mode. So you see it's gone back into find a line mode, and there we can keep tracking and into the find a line mode. So you can now digitize contours a little bit like the create shapes from underlying shapes option, except that the shapes are being automatically recognized from a raster image. And we can go on and pick another line down there and do that. We'll just do 1 or 2 in here. The algorithm is still being enhanced all the time. So the developer tells me we've done something about the speed recently. I just switched off the tracking there to get over the annotation, jump to the other side. And when you get to these complicated areas where you have a lot of lines overlapping, it actually does a reasonably good job. You see it's managed to track its way through there. But after a while, you get to know the algorithm and it's what its limits are in terms of how much it can cope with noise like that. I like to make the analogy, it's a bit like taking your dog for a walk. If you're generating a contour map, you might want to start stepping through lots of different contour levels. So if we wanted to say skip from the 10800 to the 10750, we actually have some hotkeys we can use, and I can use the square brackets to change the contour levels. So in the bottom left-hand corner of the screen, you see we can toggle through contour levels in there. And I could now start digitizing my 10750 line in there. And I'm going to get very brave and probably mess something up really badly. So here we go. We had that. So that's a quick overview of how the contour digitizing works. It's actually quite productive. Once you've created your contour file, you must remember to say file save. So we're still editing the contour there. So let's just go file save. So please do remember to save, because we have people who press the wrong save button and don't keep their information. Having created the contour file, you may want to then edit it. So you go back and you're still in editing mode on the contours, and you see it's created a beautiful line up there. And you have access to all these different tools, such as the smoothing and the bending and all the other great tools in Petrosys for editing contours to fix it up. And now in practice, this particular map that we have been working with, I actually worked on that a couple of days ago, and I was actually able to digitize all the contours and all the faults in that probably in about just over an hour, and then I spent another sort of half an hour or so creating a surface model out of it, which really takes us back to the PowerPoint. So we were able to create this great surface model of the Grand Isle block probably in about 2 hours work total, including the presentation. So that's a quick overview of all the great things that we've got for raster to data conversion in Petrosys now. The raster to grid, which converts colorful images into grids. You've got all the surface modeling facilities to manipulate that grid into something, a smoother surface. And we have two different options for converting raster data into vector images. One of them is like a bulk raster to vector conversion, and the other is the augmented tracing of lines like contours, faults, and other things from raster images. So we thank you for your attention. I don't know if we've got any questions in the Q&A box. If you're interested in this functionality, please do call our support line. The support team's always happy to hear of practical examples, and if there's something that you think can be tweaked a little bit, we're always open to suggestions. We know that a lot of you spend quite a bit of time digitizing old maps, so we thought about you. This functionality is all available in Petrosys 20.2, which is about to be released. Thank you very much. And now on that, do you know any good sources for public images? Oh, that's a tricky one. It's amazing what you can see when you Google things, actually. We've been doing some work in part of South America lately, and when you Google quite specific things, you end up with quite specific images. What you need to be careful of is that you're not encroaching on copyright and things like that. So, for example, the image we used for the South African solar resource potential, that's actually available for commercial use because the World Bank's trying to encourage people to build solar energy plants. And obviously things you get from the USGS has a lot of interesting maps. So for example, the Grand Island structure map came out of a filed report with the USGS from the Gulf of Mexico. Very good, thank you for your attention, and please do join in again for another Petrosys webinar. Thank you.